Hey, all right. So in this lecture, we're going to talk about the development system. We talked about the target system last time, and now we're going to talk about the development system for a few slides. It's a pretty short one. All right. So again, this is section 0.2 from the book. You should check out the website for the book, the companion, and all that. The development system, which we can visualize as shown in this figure here, is what we're going to use to program the target system computer, the target computer. So it enables programming the real-time target computer and typically runs on a PC with a hypervisor to manage virtual machines, or VMs. So the D1 development system, we have a development computer, which is usually a PC. It has to be, for the one that we're distributing, an x86 processor machine, which are PCs and older Macs. New M1, M2 Macs and stuff. We don't have that development system worked out yet, but it's coming. For now, it has to be an x86 PC. We're going to install a hypervisor, which will allow us to create a virtual machine. So a guest operating system on that virtual machine can run as an application under a host operating system, creating an emulated computing environment. So we're going to have the development computer here is usually a PC, can be an older Mac, Intel Mac, and it could also be an older Linux machine, or a Linux machine that's an Intel Linux machine. Those are all fine for the development computer. And then the guest operating system that we're going to install in this virtual machine is going to be Windows, though. Okay. So this is an emulated computing environment and should be identical on any of these host machines, which is why these virtual machine development environments are widely used for code development for their flexibility, enabling identical software environments across different PCs for team collaboration. Okay, so this is something that happens in industry quite a bit as well. An integrated development environment, such as Eclipse, simplifies development by combining source code editing, building, compiling, and debugging tools. So this is the innermost aspect of the development environment, is the IDE, which is a software app that brings together all this functionality. And this is where we're actually going to be writing the code, editing the code, building the code, compiling it, deploying it to the target as well. So that's the development environment. Specific D1 development systems, including their VMs and the Eclipse IDE, are distributed via the companion website, so please check that out, with lab exercise 0 focusing on familiarizing you with Eclipse and its debugger. So this chapter is sort of an orientation chapter where you're getting kind of a high level of what we're doing here and getting that all set up so that you have your own development environment is a key aspect of going through chapter 0. At this point, I want you guys to pause this video, go to this URL, and set up your development environment. The instructions are on there. There's actually a video on there as well. So you can watch the setup in a walkthrough format. So I encourage you to do that at this point, and the rest of this lecture is better if you've done that. So pause this and then come back. Okay, I assume you've got it installed now. The Eclipse workspace and Hello World. In the video, I kind of showed you some of this, but I wanted to go over this at a kind of high level. An Eclipse workspace is a directory containing projects, settings, source code, libraries, and executable files. So the workspace appears in the user interface for Eclipse in the Project Explorer here on the left-hand side. A template workspace is provided in the VM shared folder, which has this directory in the virtual machine, containing libraries for the MyRio and template projects for lab exercises. So that all appears here. Okay. Import preferences here. So these actually seem to be coming in by default right now, but you can do this just to double check to make sure you got all your preferences correct. The Eclipse user interface, which is shown over here, is organized into perspectives. So here's a perspective bar right here, with the C++ perspective being the primary interface for developing code. So this is mainly where we're going to be, the C perspective. We will occasionally need to come over to the Remote Systems Explorer perspective and the debug perspective. So that's those will be described more later on in Lab 0, actually. We'll talk about those. Here's the editor. Here's where we're going to write code in here. The console is what we'll use to monitor what happens when we compile our code, make sure that it compiled without errors. We deploy our code. When we run our code and we print something to the console, it's all going to appear in this frame. Okay. Git is recommended for version control and collaboration. An introduction to Git is available in Appendix C of the book. Really, we should be managing this workspace in a version control system. It's probably Git, which is the most popular one. In the Appendix C of the book, we go into how to create a Git repository for the workspace and to manage your code using Git, which is how professionals do it. And it's a good skill to learn, although we often move right past it in courses because it bogs us down from whatever we're specifically trying to work on. So it's worth spending the time to learn. I remember a developer that I met in grad school who told me that version control changed his life. That it was his life could be split into before version control and then after version control. I don't know if we're all quite as floored by version control as he was. John Jackie was his name. Great guy. But in any case, version control is extremely useful for working on a complicated software project, or really any software project. All right. Very good. Let's carry on. So this is what the Hello World project looks like in the Project Explorer. So the workspace is the top level directory. Inside of the workspace, we have these directories. So we've got, to start at the top, a .metadata folder, which is the Eclipse workspace settings. It's best to leave that alone for the most part. It's really easy to corrupt your workspace so that Eclipse does not know what is going on with your workspace anymore. So something to be aware of. Mainly stay out of there. See support for MyRio. This is something that National Instruments supplies with the MyRio, that we will build some of our applications using some of their code that they provided as well. The T1 library is the library that we provide as part of the book, and so there's some functions in there that we'll be using throughout the lab exercises. Remote systems temp files. So we get some of our remote files from the target computer will show up here, and we'll start to need those in some of the later labs. So we'll look into that folder later on. Hello World is a basic project that can be compiled locally, so you don't need to have a MyRio to start writing C code and to get Hello World working. And in that video that walks you through installing the D1 development system, we show how to edit Hello World and build it and all that. Labs 0 through 8 have these stub folders or template folders, and in here is just a basic main .c file, and it has all of the header files included automatically so that you don't have to do that for each of the lab exercises, so that you have a working starting point for each of the lab exercises. So labs 0 through 8 have those, and this is where you're going to write most of your code. Hello World is a place for you to play around with your code and or with any C code, getting used to the C programming language. But when we start writing code for the labs, those will be in these lab 0 through 8 directories, and then the README file. Okay. Good. So right now, if you open up the Hello World project and the main.c file, you'll see that printf prints here to the console. By default, that's what it prints. So in the walkthrough, I showed you how to edit the main function so that it now says Hello World, and we build it with project build or Control B. Check the console to make sure it builds correctly. Refresh the Project Explorer if the debug directory does not appear after building. It usually does, but occasionally you'll have to refresh it. Run the program within Eclipse using the Run Configurations dialog. Select C, C++ application, and the Hello World configuration. The console output should display Hello World after successful execution. So that should all work. And if that's all working, you are ready to move on to the next section. All right. Take care.